Hello everyone, today we will study Ohm's law and we will learn how to connect a series circuit using this is our battery, and depending on how you connect them, there are 4 different voltage choice, and this is the ammeter to measure current, and it can be connected with the computer, the logger program, and this is the voltmeter, and these are cabled, and these are some resistors. So for example, this is 47. You can take a look at the color code. So this one starts with yellow, violet. This one is the 68 ohms. It starts with the blue and the gray, and this one is the 10 ohms. So the first one is this is the brown, black, and this is the 100 ohms. So we have brown, black, brown, and you see the golden one. So the first 2 represent the first 2 digits. Brown is 1, black is 0, so 10. The third represent the power, so this is 10. So this is 10 multiplied 10 to the first power, so that's 100 ohms. And the gold, that tells us the uncertainty. So the variation is the plus or minus 5% of the original value. Next, I'm going to show you how to connect a series circuit. So let's start with the battery. And there are black, there are red. So battery has positive and negative side. So the current come out from the positive side of the battery and come back to the circuit from the black one. So I have current coming out from the battery, and enter the ammeter. You have positive and negative side. Enter from positive side and then come out from the black. Coming from positive, come out from. Next, I'm going to start with the 10 ohm resistor, and I need 2 alligator to connect the resistor in the circuit. For resistor, there is no positive or negative side, so it doesn't matter you choose which side to come in. There is no polarity. Now I have the 2 resistors connected with the alligator and another cable. This one come back to the circuit. So this will be a closed circuit. And next I'm going to connect the voltmeter to measure voltage across the resistor. So for voltmeter, it must be in parallel. So for voltmeter, there is a positive and negative sign. So the red one is positive and the black one is negative. So because the current come out from there, so this side positive, this side is negative. Now I have my voltmeter that's in parallel with the resistor. Next, I'm going to connect the voltmeter with the vernier software. Now I have the circuit connected. Next, I'm going to open the logger profile. Before I start measuring the voltage and the current, I'm going to zero both the ammeter and the voltmeter first. And from now you see the potential and the current, they're not zero. So to zero it, I'm going to disconnect the voltmeter. And there's no current. So now the current is 0, I'm going to zero it. Good. Now both potential and the current, that's 0. Okay, next I want to connect my voltmeter back. Okay. Okay, now we are ready to do some measurement. This is like a switch. I'm going to start with the lowest voltage, 1.5 volt. Now I have a closed circuit, and now you see the potential and the current are not zero anymore. So I'm going to click collect, and you see a red dot there. I'm going to click keep. And next, let's try different voltage. Now I'm going to double the voltage, and look at that, the current, this is the 0.26, and this is the second dot. Keep. Now I have all my data. I tried 4 different volts. I'm going to stop, and since I'm done the measurement of this resistor, I'm going to disconnect it. Just open the circuit. Now if you look at the data here, this column is current, this column is the voltage. So initially the voltage is about 0.89, and this is 0.13 ampere. When I double the voltage, current is almost doubled. This one, the voltage is almost tripled, the current is almost tripled. So it's a very linear relationship. Let's try linear fit. Highlight the data, try linear fit. And look at that, it's a very good line. So the slope of this line gives me 6.468 volt per ampere. So this is the voltage of the resistance I'm using here. So according to the color code, the resistance should be 10 ohm, but according to my actual measurement, it's actually 6.46. So there is already a difference between the manufactured value and the actual value now, because these resistors are pretty old. By repeating the same procedure, this is the data I got for the second resistor. Again, I'm going to do linear fit. Find the slope of this line. So the slope is 45.9 volt per ampere. So the resistor, this is the color code I'm using, so you could read from this side. So the first one is yellow, violet, and black. Next, I'm going to replace the resistor with this light bulb. So, and again, light bulb is like resistor. There is no polarity, no positive or negative side. You can connect either way. Now I have the light bulb connected in the circuit. Let's start with the lowest one. Oh, look at that. It's bright, but a little bit. Now let's change the voltage. Whoa, it looks like it's brighter. Now let me try 4.5 volt. Wow, that's brighter. Let's try 6 volt. Wow, that's very bright. This is the data I collected for the light bulb. When the potential increased from about 1.3 volt to 2.6 volt, current is not doubled. Current go from 0.2 to 0.3 ampere. So current is not proportional to potential for this light bulb. Let's try linear fit. And if you look at this one, the dots actually not line on the line exactly. So linear fit is not a good try. I'm going to try curve fit. So let's try exponential function. This one. I fit. And now I have all my dots for exactly on this line. And you can see it's actually part of a curve. This is very different behavior compared to the previous 3 resistors that we started.